So the first thing that we're going to do is we're going to look at a little reaction between a compound that we call copper chloride, which is this stuff right here, this nice bluish greenish liquid, and aluminum foil. Now, when we're making observations in the lab, and I wish, it kills me that we can't be in the lab together because I love doing lab with you guys. It's so good for cementing learning. But when we're in the lab, we have to be great observers. We want to watch and take note of what's happening so that we don't miss stuff. And when we're observing things, our observations fall into two basic general categories: qualitative and quantitative. Quantitative implies quantities, which are like numbers. So quantitative observations are always going to include numbers, like I put 50 milliliters of the copper chloride solution in here. That's a quantitative observation. It involves a number. But numbers aren't everything. A lot of the times we'll use qualitative observations because qualitative observations help us note features that you can't number. Like you can't put a number to the fact that this aluminum foil is shiny. That's a qualitative observation. Okay, we can't describe the shape of the aluminum foil with a number. We would just say, hey, it's crinkled into a little ball. So those are examples of qualitative observations. Now, when we're making observations, we are making observations of the different properties of matter. And those properties fall into two basic categories. Things like physical properties or chemical properties. Physical properties we can just make direct observation of without anything else. So like, it's shiny, it's blue, it's a liquid. And those are examples of physical properties. Chemical properties are only apparent when a chemical reaction occurs. Sorry, I gotta get should be wearing my safety glasses and demonstrate good lab technique here. So for this first experiment, we're going to put some aluminum foil into our copper chloride solution. And we're just going to make a few observations. This guy is, I'm going to bring this over so you guys can see it. So you can see, maybe you can start to see, we're starting to get some little bubbles on there, little fuzzies on our aluminum foil. And we'll come and take a look at him again in just a little bit. We're going to let this guy go for a little bit. And while we're doing that, I'm going to get set our next one. So we're going to let this aluminum foil and copper chloride sit for a little bit, and we're going to work with our next experiment. Make sure that's okay. So in our next experiment, we're going to add some hydrochloric acid to a beaker. So we can make a couple of observations about our hydrochloric acid. Hey, it's a clear, colorless liquid. So we're looking at physical properties there. And this is sodium carbonate, also a clear, colorless liquid. So what's going to happen when we put two clear, colorless liquids together? Anybody?
You're going to get a reaction.
And what would that look like?
A clear, colorless liquid, yeah, it'd stay clear.
Okay. So we've got some options here. We've got a reaction. We've got two clear, colorless liquids equals a clear, colorless liquid. Well, let's watch and see what happens. So we'll put some drops of the sodium carbonate in there. Was it a clear, colorless liquid that resulted? Yeah, it turned purple real quick, right? So if I give it a little swirl, though, Now it's a clear, colorless liquid. So it turns color, then I swirl it up, and then it goes back. By the way, that's a common chemistry technique. We call it the magic swirl. It makes things disappear. So let's try it again. What would happen? What do you think will happen if I add a second little squirt here?
Purple.
Okay, we'll see. So I add a little squirt. We get that nice pink purple color. Magic swirl. Voila, goes away. If we do it a third time, now our purple's staying in there a little bit. Oh, now it's gone. Comes and goes, comes and goes. Do you think I can do this forever?
No, because wouldn't like the clear purple solution take up more of the clear solution that you put in before, making it purple?
So you think the purple, where's the purple going when it disappears? Is it like covered up by the clear solution, or? Well, let's try it again. Give another squirt. Doing a magic swirl. Oh, there it goes. It's gone again. Another squirt. Oh man. Oh. Is it gonna go? One more time. I think this might be the one. Yep. Okay, now it stays purple or pink or whatever color that is. I'm actually kind of colorblind, so I'm not that good with colors. But it stayed that time. So this is a really well. Let's go back to what I think it was it Haley? Haley, did you say that we were going to see a reaction?
Yeah,
How would you know that a reaction has happened?
because it's changed colors.
Very good. Okay. One of the clues that a chemical reaction has occurred is that we get a change in color. So we see a color change right here, right? Another piece of evidence that we get a chemical reaction has occurred is that we see bubbles. Oh, what do you guys see on the foil there? Bunch of little bubbles. We got bubbles. And what happened to my nice shiny foil? Above the water line, it's still nice and shiny, but below the water line, it's not so nice and shiny anymore, is it? You get some brown goop on there. That's what we call a precipitate. It's a solid that is formed out of a liquid. And so that's another piece of evidence that a chemical reaction has occurred. So we've got color change, we've got precipitate, we've got bubbles. I want to take a second and talk about what's happening here in the beaker, though. This is an acid-base reaction. Hydrochloric acid is an acid, and sodium carbonate is a base. There was one other thing in there that I didn't tell you about, though. That was an indicator called phenolphthalein. And when you are using phenolphthalein, if the pH is below 7, it's going to be clear. If the pH goes above 7, it turns pink. This is an acid. This is a base, right? So it was clear when it was in the hydrochloric acid by itself, but when we added a little squirt of sodium carbonate, it showed up, right? Because we put a little bit of base in there. And so we were adding acid and base together. And when we had a lot of acid and just a little bit of our base, eventually the base would disappear. And that's why it became clear. Until we added enough base that we had more base than acid. And at that point, it stays pink. There's a whole branch of chemistry called acid-base chemistry that is concerned just with these types of reactions. And it's actually incredibly important biologically because it controls some certain features, even has a role in oxygen uptake in our bloodstream, this acid-base dynamic. So we have one more experiment that we want to look at really quickly here. And in this experiment, we're going to take some acetic acid. We're going to put it in this little container right here. Where'd that guy go? Oops, got to grab one more thing.
How do
Okay.
you want us to do the drawings on the?
You guys actually don't need to do the drawings.
Okay.
That's a great question. Thank you.
Since I don't have the book yet, do you want me to just determine if that's like the copy, or do you want me to like write it back down on the?
No, this one you guys can. This one you guys can do on the doc. I want you guys to do this one on the Google Doc. Your copy of the Google Doc.
Okay, well that's what I've been doing. I didn't know. If
Perfect.
I can
Yep.
Copy it down once I get the book.
Nope, you're good, Jonathan.
All right, thank you.
So with this last one, we're going to take some sodium bicarbonate, which is a white powder, and we're going to put it in with our acetic acid. Let's do this a little bit more. Nobody blink. Woo! All right. What happened?
It blew up.
It blew up. Why did it blow up?
That
It built up pressure.
yeah, that
Okay. So what built up pressure though?
probably the bicarbonate mixing or like combining with the acid. I'm guessing.
So they did the sodium bicarbonate did combine with the acetic acid. By the way, sodium bicarbonate is baking soda, and acetic acid is
Vinegar.
vinegar. Okay. So yeah. Sounds a little bit fancier when we say sodium bicarbonate and acetic acid though, right? So if you could see on the table, there was more bubbles, right? And that reaction we know produces a lot of gas. So we get the gas inside a fixed container, and as a result of it being in a fixed container, the gas expands, and as we make more and more gas, it tries to expand and the pressure builds up until the container can't take it anymore. And boom, pops off the lid. Okay, it's a simple little explosion. Now, the same principles